Assalamualaikum and hi everyone. My name is Nur AUNI QISTINA binti ASHRAF and my matric number is 2023462758 and I'm from group RCDCS1433E.
Hi and Assalamualaikum. My name is SYAHIRAH NAJWA binti HAFIZ and I am from class RCDCS1433E and my matrix number is 2023461072.
Assalamualaikum and hi. My name is SHUHADA binti ZAINONZAMAN. It is number 2023497828 and I'm from RCDCS1433E.
Hi, my name is HAKIMI bin SAZALI. My student number is 2023638184.
I will start by stating the objective of this experiment. Firstly, the goal is to observe and record the frequency of each of these car brands, Proton, Honda and Mercedes, in our data collection. Secondly, we will calculate the probability of obtaining each car brand, which is based on the frequencies we recorded. Finally, we will compare the experimental probability based on our actual data with theoretical probability, which assumes equal chances for each brand or uses market data. This will help us to see any differences between what we observed and what we expected.
Okay, now I'm going to explain about chapter 2, methodology. So, the data we collected for our experimentations for populations includes all 30 students from class RCDCS1433E. Next, for our sample, 20 students of our populations selected randomly for analysis. And for our sample space is Honda, Proton and Mercedes. Okay, so now we move to chapter 3, result and interpretation. For question A, we observe and record the frequency of each car brand. So we provide the table here for our experiment. So first brands is Honda. The total car brands are 12 and the frequency are 9. Next, Proton. The total car brands are 8 and the frequency are 5. And lastly, Mercedes. The total car brands are 10 and the frequency are 6. So here we can see that the total number of car brands of Honda is the highest. So the probability to get a Honda car is much higher than other car brand. Okay, next question B. What is the experimental probability of obtaining each of the brands, which is Honda, Proton and Mercedes? To get the probability of experimental, the frequency of each brand need to divide by the total frequency, which means the total sample. So first, the probability experimental of Honda is 9/20, which is 0.45. And next, for the probability of experimental for Proton is 5/20, which is 0.25. And lastly, the probability of experimental for Mercedes is 6/20, which is 0.3. So the experimental probabilities are 45% for Honda, 25% for Proton and 30% for Mercedes, reflecting the relative frequency of each brand in the observed data. Which means if we sum up for all the probabilities each car brands, 45%, 25% and 30%, we got the 100%, which means the probability. Okay, next question C. What is the theoretical probability of obtaining each of the brands, which is Honda, Proton and Mercedes? So to get the theoretical probability, we have to divide the total of the specific brand by the sum of the total, which is the total population. So first, for Honda, the theoretical probability is 12/30, which is 0.4. And for Proton, the theoretical probability is 8/30, which is 0.27. And lastly, for Mercedes, the theoretical probability is 10/30, which is 0.33. So the theoretical probabilities are 40% for Honda, 27% for Proton and 33% for Mercedes based on the total car brands recorded in the data set. This provides the expected likelihood of selecting each brand under ideal condition.
Okay, now I am going to explain about question D. So the question is, what is the difference between experimental probability of obtaining Honda brands and the theoretical probability of obtaining Honda brands? So we need to write the answer as a percent rounded to the nearest whole percentage. So the formula is PEH minus with PTH. So PE is the experimental probability of Honda brands and PTH is the theoretical probability of Honda brands. So PEH is 0.45, so we need to minus with PTH, which is 0.40. So the answer we need to times with 100 to get the percentage. So the answer is 5%. So the conclusion for this question is, out of 20 students choosing their favorite car brands, there is 5 students choosing Honda brands over the theoretical probability. Now we move to question E. So the question is, what is the difference between experimental probability of obtaining proton brands and the theoretical probability of obtaining proton brands? So we need to write the answer as a percent rounded to the nearest whole percentage. So the formula we got is PEP minus with PTP. So PEP is the experimental probability of proton and we need to minus with PTP. PTP is the theoretical probability for proton. So PEP is 0.25 and we need to minus with PTP 0.27. So the answer for that we need to times with 100 to get the percentage. So the answer is 2%. In this experiment, out of 20 students choosing their favorite car brands, there is 2% of students who are not choosing proton brand over the theoretical probability. Okay, now we go to question F. So the question is, what is the difference between experimental probability of obtaining Mercedes brands and the theoretical probability of obtaining Mercedes brands? So we need to write the answer as a percent rounded to the nearest whole percentage. So the formula is still the same, PEM minus with PTM. So PEM is the experimental probability of Mercedes and PTM is the theoretical probability of Mercedes. So for PEM, it is 0.30, so we need to minus with PTM, which is 0.33, and the answer for that we need to times with 100 to get the percentage, and the answer is 3%. In this experiment, out of 20 students choosing their favorite car brands, there is 3% of students who are not choosing Mercedes brand over the theoretical probability. Okay, now we go to question G. The question is, what is the experimental probability the selected brands are not Honda? So the formula is 1 minus with PEH. So PEH is 0.45. So we need to put the value in the formula. So 1 minus with 0.45 and we got 0.55. So the experimental probabilities of selecting a brand that is not Honda is 0.55 or 55%.
Conclusion, Honda was the most preferred brand with Mercedes and Proton following closely behind choose by the student. The findings from our assignment contribute to our understanding that the data we collect is crucial in determining how to accomplish the main objective. The experimental probability does not always equal the theoretical probability. As we compare theoretical and experimental probabilities and conduct more trials, we begin to notice a pattern. The more trials that we run, the closer the experimental probabilities will be to the theoretical probabilities of the event. Next, let's proceed to the stats question. The random variable x has a summative distribution function given by picture below. To find a probability x greater than equal to 2 and less than equal to 6 is, we can simplify it as FB minus FA. And our A is 2 and our B is 6. Next, we can substitute our x to 6 and 2. And we can simplify, we can get our answer is 7 over 8. Next question, to find the probability density function for x greater than equal to 1 and less than equal to 3, we have to differentiate x minus 1 square over 12. And we get the answer is x minus 1 over 6. For x is greater and equal to 3 and less than equal to 7, we can differentiate 14x minus x squared minus 25 over 24. And we get 7 minus x over 12. After we differentiate, we can make it and simplify it as to the form picture below. Next question, to calculate expected value to x plus 1, we must separate 2x and E1, 2ex plus E1, and let 2ex is 1 and E1 is 2. For the first one, for 1, we have to integrate from limit 1 to 3x in bracket x minus 1 over 6, and we get the answer is 7 over 9. For 2, we have to integrate from limit 3 to 7, which is x in bracket 7 minus 6 over 12, and the answer we get 26 over 9. And we have to sum up 1 plus 2, which is 7 over 9 plus 26 over 9, we get 11 over 3, and final answer is 25 over 3.